Hey, everyone, how's it going? This is Dan here from PromptHub. Welcome back to the YouTube channel. Today we're going to be looking at a really interesting study that is the closest thing we have to a controlled experiment of AI versus human in the real world today. And so this study comes out of Durham University in England, and it's a comparison of physics students taking a 10-week coding course in Durham against GPT 3.5 and GPT 4. And so they do a really good job making this a controlled experiment. And so it's a really good insight into exactly where the models are at in a kind of knowledge-based task. And so, again, it's a 10-week course. It's a physics university level. It's a lot of coding and experimentation involved in the course. And they use Python for all of the tasks. And so for this experiment, the specific setup, they basically take, for a specific homework assignment that involves writing Python, 50 student submissions and then 50 AI submissions generated with 5 different methods. So it'll be 5 methods, 10 submissions from each of those methods, and we'll look at those in a sec. And then there was 3 graders who blindly graded each of the submissions. And so there'll be a performance for each. And so 6 methods in total, 5 AI methods, GPT 3.5 with some prompt engineering following some guidelines, which we'll look at next. GPT 4, and they're using the Turbo model, which came out in November of last year. GPT 4 with prompt engineering. They ran a mixed category where they randomly added in student and AI generated pieces of the submission and to make one whole, and then the last one is just the student ones. So the guidelines they added were pretty basic ones, followed a lot of the OpenAI guidelines, a lot of the guidelines that we talk about on our blog, but some of it's just cleaning up how the functions are being defined, removing unnecessary information, adding a little preamble for context, using here, to kind of structure the prompt of where code is supposed to be inserted, and some more details. So pretty straightforward stuff, I would say. There were a couple of limitations to the study, although I still think it's very controlled for as much as you can. But for one of them, there was no way to be 100% certain that the students didn't use AI in their own submissions. They, of course, were instructed not to. But you can never know with college students. And then secondly, the researchers actually had to pre-process some of the data to make the prompts work with the LLMs. So for example, the LLMs had trouble with some of the tables that it was being sent, and so they had to kind of update those to be Python dictionaries instead. And it's subtle, but it's an important note, the assist that the LLMs are getting here. So it's not, I would say, an apples to apples comparison in that way because of this slight limitation. So without further ado, let's jump into some results here. And so as we can see, these green bars relate to the student human submissions. And so for now, the humans were able to kind of win out in this one with the average score of 92%, beating the next highest AI method by about 10 percentage points, with GPT-4 with prompt engineering coming at around 81%. And so that's great for the time being. I think a couple other interesting takeaways. You obviously see jumps when you just take a basic prompt versus the kind of with prompt engineering. So GPT-4 goes from 71% to 81%. It's like a 13% increase. GPT 3.5 goes from much bigger jump from about 30 to 48, which is like a 60% increase. So a common thing we see is that a little prompt engineering can go quite a long ways, especially with models that are maybe older or smaller or not quite as smart. We're seeing a bigger effect there. And then lastly, I think it's just always good to note just how drastic the performance change is from GPT 3.5 to 4 here, going from 30% to 71% is just an insane jump. There was another limitation here on the LLM side. There was some times where the outputs that the LLM was generating either had broken Python code or just wasn't Python code at all. And so the researchers had to rerun those prompts and many times until they got those 10 submissions that they were looking for each category. So again, it's another subtle thing, but it's another instance in which the LLM is getting a little bit of an assist here. And so after the performances were graded, their submissions were graded based on performance, they asked the 3 graders to then rate these submissions on a scale from basically 0 to 3 of how likely they thought it was AI or human. So they used a Likert scale, which is what it's called, going from definitely AI to definitely human, with definitely AI being a score of 0 and definitely human being a score of 3. And we can see they actually do a really good job of it. We're seeing, big green chunks on the definitely human side and small green chunks on the AI side, which is, generally the shape you would want to see. And if we look at the averages across the different methods, again, 0 is AI and 3 is human. They do a pretty good job across the board, with GPT 3.5 coming in at almost 0 itself. You can see with the prompt engineering, the likelihood that the researchers would think it's human goes up. So we go from 0.03 to 0.2, 0.4 to 1.1. That's probably just because the performance gets better, and in this case, better performance correlated with human outputs, since they were kind of one and the same here. So overall, the researchers did a good job setting up both of these experiments. The graders did a good job of being able to actually identify these things. They saw some interesting patterns emerge that I think helped them figure out if it was AI or not. Specifically, the human results or submissions were more likely to have kind of bolder design choices, while the AI ones were going to use kind of standard formats and colors for things like tables. So it speaks to a really interesting point about human creativity and how we are, much more subjective in our decision making versus LLMs, who are trained on all these, big troughs of data. Last kind of thing to look at here was just a little bit of an additional comparison of unique words and average word length. You can see they're both really similar, which I think is the main takeaway. We could talk about how AI is has a little bit longer words, and we've seen this in other studies too, and there's slightly more unique use of word set. I think the really interesting takeaway is just how close the two categories are in both of these metrics. And so, again, this is a really great study because it's as controlled as it can get. It's not a random benchmark or a random demo, and so that's why we really liked it. And it's something I think a good one to kind of look back on in 6 months, 10 months, 12 months, as we look for more studies like this to see how these things progress. We would love for them to do a follow-up one, but again, it's a snapshot in time of where we are currently, which is why I really like it. And so, happy prompting. We have a rundown of this whole article, which I've linked below. So feel free to dive deep, add any comments, any questions, anything along those lines, and yeah, see ya.